Hi, it's Mr. Anderson, and welcome to Biology Essentials Video 49. This podcast is on cooperative interactions in living systems. Before we get to living systems, let's talk about war and peace for just a second. Now, game theory is a way to predict the strategy that people are going to have or living beings are going to have before they actually do it. And so peace and war is a good one to talk about. And so let's say the year is 2012, and the country of Finland decides to invade Switzerland. Now, it's probably not going to happen. They both have these neutrality agreements that they've signed. But let's say that Finland decides 2012 we're going to go to war with Switzerland. Okay, so if we look at the payout over here, so let's put Finland on this side and we'll put Switzerland over here. Finland is going to gain, we'll say, 3 units, and Switzerland is going to gain 0 units from that. So if Finland invades and steals all of the Swiss Army knives in Switzerland, they're going to gain from that. Switzerland gets nothing from it. So that's kind of how the payout is going to be laid out. And so you might think that's cool for Finland. They're able to grab things and make off. But the problem is that now 2013 comes. So 2013, Switzerland has lost all their Swiss Army knives, and now Finland decides, well, let's go at it again. So they decide that worked really well, so they're going to go to war. And Switzerland, this time they're going to steal all the Swiss watches from Switzerland. And now Switzerland's kind of irritated. They've signed this neutrality act, but now they're irritated. So the next year, Finland's going to come at them again. So they go to war, but this time, Switzerland's going to figure from this that they're going to go to war as well. So now we have mutually, for the next 3 years, they're in this giant war. So let's imagine that happens until 2016. So now let's see how this all played out. Well, Finland initially got 6 points, but then they eventually ended up getting just 3 more. So they have a total of 9. So Finland ended up with 3. And so let's say that's one possible future. It's probably not a very probable future. But now let's say that Finland decides, you know what, we've got, let's start kind of trading with Switzerland. So we'll get their Swiss Army knives and we'll export the video game Angry Birds to them, which was created in Finland. And so they decide to go at in peace. And so let's say 2 and 2, and peace continues through time. And then if we look at the game theory numbers that we get here, after 5 years it'd be 10 and 10. And so not only did Switzerland do way better, Finland did way better. In other words, you're better off if you're at peace. You're better off with cooperation. And in fact, that's the strategy that you should adopt. You shouldn't go to war, but if somebody does provoke you, you're going to have to come back at it. And we find that countries that are continually at war are actually not the richest countries truly on our planet. So in this podcast, we're going to talk about life. And so how life cooperates to utilize matter and utilize energy. And so I'm going to talk about this cooperation threefold. First of all, we're going to talk about how single cells cooperate, all the cells that live in the rumen of a cow, for example. We're then going to talk about how cell parts cooperate, how the plasma membrane works with the cytoplasm and other organelles. And then finally, we're going to finish with the larger level, how organs cooperate. An example we'll talk about is digestive system. So again, cooperation helps everybody who's involved. And so if we think about the rumen of a stomach, or the rumen of a cow is going to have multiple parts inside their stomach. They're going to eat the food, it's going to go down into the stomach, it's going to actually go back into their mouth, where they chew their cud, and then it moves back into the stomach. But I'm not concerned about the cow right now. I'm concerned about the things that live in the gut of the cow, or in the rumen of the cow. And so what are some things that live here? Well, bacteria and protozoa. Bacteria are going to be these single-cell prokaryotes. Protozoa are going to be these microscopic animals. These make up like 60% of the organisms that are living in the gut of the cow. We also have some fungi, like some yeast. We also have some archaea, and then we also have viruses that are living there. And so all of these things inhabit the gut of a cow, and all of them have to cooperate for their mutual benefit. And so what do the bacteria and the protozoa do? Well, the bacteria are going to be able to break down a lot of the material, the cellulose that's going to be found in that plant material, so they can utilize it. What's the function of the protozoa? Well, some of them can also secrete enzymes that break down that material, but they're also going to keep the bacterial population in check. What about the fungi? Well, the fungi are important, even though they make something like 5% of the living things in the rumen. They can break down specific bonds between the lignin inside the cellulose. And so if it weren't for fungi, they wouldn't be able to digest this fully. They couldn't get all their nutrients, and so they rely on the fungi. So there's this reaction. What about archaea? Archaea, remember, are those ancient life. Well, the important ones inside the gut of a cow are the methanogens, those that break down methane gas. Because if we didn't have a buildup, if we had a buildup of methane gas, that would actually kill the bacteria, the protozoa, and the fungi. And so they're relying on the archaea. What about viruses? You might think, what could viruses possibly do? Well, viruses will actually kill bacteria, releasing their nutrients, and so they can be used by other things inside the gut. And they also keep that bacteria in check. And so all 5 of these organisms and all the probably millions of different species inside the cow gut have to cooperate. They all have to work together. And if it weren't for them working together, the cow wouldn't be able to eat what it does, and so it wouldn't be able to exist as well. So these are cells that are cooperating. Let's go to the level of within the cell itself. And so let's say we're talking, for example, inside the liver. Let's say this is a liver cell. Let's put an R there. So liver cell is important because it stores glycogen. So that glycogen is going to be glucose that's attached together, we'll draw that in black, inside here in the cytoplasm of the cell. And so occasionally your body needs that glycogen to be broken down into glucose. And so you'll have a chemical. That chemical will bond with proteins on the plasma membrane. If the plasma membrane isn't helping, then this stops there. There'll then be a cascade or a signal transduction pathway, which will move throughout the cytoplasm. So we require the cytoplasm. It sometimes can trigger a response inside the nucleus, which releases proteins, messenger RNA, which creates proteins, and those proteins can break down that glycogen into glucose, which we can eventually leave the cell. And so now we have cooperation between many parts of the cell. If it's not for the plasma membrane, the proteins here, the gene regulation in the DNA, the using of the ribosomes, the cytoplasm, if they're not all working together, we have a cell that's not going to function. And so this is functioning, or cooperation between organelles. And then finally, we could talk about a whole system. So not only cells working together, but organs working together. Example I've chosen to talk about is the digestive system. So digestive system, what's it doing? It's taking in food, it's breaking it down so we can use the parts, but it has to cooperate as well. And so there are 4 things that we have to get nutrients from, and those are 4 major macromolecules. Those are the carbohydrates, but we'll talk about the other ones in just a second. So where's the digestive system start? It actually starts with the eye, and that's a creepy looking eye. But the eye is going to see what I'm about to eat, and it's going to start, I'm going to start to salivate. And so let's say those carbohydrates are a giant piece of pizza, so it's mostly carbohydrates inside there. I see that, and I'm going to start creating enzymes in my mouth. Those are called amylase, which are going to break down the sugar. It's also going to move into my stomach, where we're not going to work on that too much, but it's going to move into my small intestine, where I'm going to make pancreatic amylase, and that's going to break that down, the carbohydrate, into glucose that I need inside the cells. And so now we've got my salivary glands, we've got the enzymes in the pancreas, or enzymes in the small intestine, and the functioning of the pancreas that's causing that to occur. If we go to the next thing, let's say fats, for example. How does fats work? Well, fats are different. We're not going to digest that much in our mouth, in the esophagus, clearly not, or even in the stomach. But what we do is we start producing, in the lipases, we start producing bile, in the gallbladder. The bile is going to emulsify the fat, so make them smaller, and then we're going to produce lipases inside the small intestine to break down those lipids. Or if we move to another one, let's say we're breaking nucleic acid. Well, we're not going to do much here. We're not going to do much here, but we're going to break down a lot of those nucleic acids in the small intestine using nucleases that are produced in the pancreas. Finally, if we finish up at proteins, which is maybe the most confusing, proteins can't break those down in our mouth much, but we do produce this hydrochloric acid. We produce pepsin, which inside the stomach is going to break down those proteins. We're then going to have trypsin and chymotrypsin working in the small intestine. So we have all of these organs working together using feedback loops just to break down the food that we eat. And so again, competition is important. Competition sometimes is good, but if you can cooperate, then you have the mutual benefit of all of those constituent parts involved. And I hope that's helpful.